Hey everyone, welcome back to another video. So I found some pretty challenging isotope questions, and in today's video I'm going to break down one method that you can use to solve them. But here's the deal. If you want me to show you the other method, then drop a comment below letting me know, but after you hit that like and subscribe button. Let's take a look at it. Question 1 reads, nitrogen has two isotopes, N14 and N15. If the relative atomic mass of nitrogen is 14,007, what is the percentage abundance of each? Now, the way I do this is usually I draw a table. So in that table, I'm going to put the mass and percentage. Now, N14 means that it has a mass of 14. So the mass is 14, and the percentage we don't know. So let's leave that as x over 100. Now, the other one has a mass of 15. Now, the percentage. Do we put y over 100? We don't need to, because remember, percentages need to add up to 100. So the second percentage will be 100 minus x over 100. Now we can use this and work out the relative atomic mass. So relative atomic mass is equal to the mass times the percentage plus the mass times the percentage. So 14,007 is equal to, the first mass is 14 times x over 100 plus the second one is 15 times 100 minus x over 100. Now, I'll show you how you can solve it. What you need to do is just remember that when you are multiplying, you multiply numerator and numerator, denominator and denominator. So this one is going to be 14x over 100 plus, this one is going to be 15 into 100 minus x over 100. Now what you can do here is you can multiply everything by 100 to get rid of that 100 in the denominator. So this is going to give me 1400,7 equals 14x plus 1500 minus 15x. Now we can solve for x, right? And you solve for x, you're going to get x equals 99.3%. So that's obviously going to be this one. So N14 is going to be 99.3%. That means N15 is going to be the remainder, which is 0.7%. All right, let's move on to the next one. Question number 2 says copper has two isotopes, Cu63 and Cu65. Given that copper has an atomic weight of 63,546, what is the percentage abundance of each isotope? Again, let's draw a table. So we got mass, then we have percentage. The first mass is going to be 63, and its percentage is going to be x over 100. The second one will be 65, and the percentage will be 100 minus x over 100. Now we've been given the relative atomic mass, so let's use our formula. Relative atomic mass is equal to the mass times the percentage plus the mass times the percentage. 63,546 is equal to 63 times x over 100 plus 65 times 100 minus x over 100. And now the process is exactly the same as the previous one, and we can solve. So when we solve, we're going to get x is equal to 72.7%. So therefore, we can write out our answer and say that Cu63 has a percentage of 72.7%, and that means that Cu65 is going to be the balance, which is 27.3%. Now the calculations here are exactly the same as what we did before, so we're not going to repeat it. Let's move on. Question number 3. A sample of naturally occurring silicon consists of Si28, Si29, and Si30. So here we have 3 isotopes. If the relative atomic mass of silicon is 28,0855 and the abundance of silicon 29 is 4,67%, what are the abundances of Si28 and Si30? So here again, let's construct our table, mass and percentage. So we have Si28, Si29, and Si30. They tell us the abundance of Si29 is 4,67%. We can basically 4,67 over 100, right? So, or doesn't matter which one we use. Now, for Si28 and Si30, we don't know them. So again, we'll use x. So here we're going to use x over 100. But in this case, we are not going to say 100 minus x. That would be wrong because we have this percentage that we need to deal with. So the answer, or the way that we'll write out the percentage for Si30 is going to be 100 minus 4,67 minus x over 100. So it's basically the balance, okay? And let's just simplify that. So 100 minus 4.67 is 95.33. So Si30 is 95.33 minus x over 100. And now that was the main trick for this question. And the rest is straightforward. So we're going to go relative atomic mass is equal to the mass times the percentage plus the mass times the percentage plus the mass times the percentage. We got the relative atomic mass 28,0855. That's equal to 28 times x over 100 plus the next one is going to be 29 times 4,67 over 100 plus the last one is going to be 30 times 95.33 minus x over 100. And now this is this has no variables in it, so we can simplify this. And once we simplify it, we can take it across and then solve for x. And then when we do solve for x, we're going to get that x is equal to 93.39%. So that goes with that one. So our answers are going to be Si28 is going to be 93.39%. Si29 we know is 4.67%, and that means Si30 is going to be 1.94%. Okay, let's move on. Question number 4. Question number 4, they've given us a table now. And question 4 reads, determine the percentage abundance of Fe57 and Fe58. They've given us this table. Now there's 4 isotopes and they've given us the relative atomic mass. Now, what we can do here, just like we've done before, is we'll label this X. So we'll make it X over 100. Now, Fe58 is not going to be 100 minus x. Remember, like we've done the one before, you have to subtract these percentages as well. So Fe58 is going to be 100 minus 8,536 minus 90,007 minus x all over 100. We can then simplify. So let's put that in the calculator. 100 minus 8,536 minus 90,007, and that's equal to 1,457. So 1,457 minus x all over 100. Right? Now, we have our relative atomic mass. We can go right ahead and we can solve. So relative atomic mass is going to equal the mass times the percentage plus the mass times the percentage plus the mass times the percentage plus the mass times the percentage. Remember, there's 4 of them. Now we can substitute. We have 55,845 equals, the first mass is 54 and its percentage is 8,536 over 100. The second mass is 56 and its percentage is 90,007 over 100. The third mass is 57 and its percentage is x over 100. The last one is 58 and its percentage is 1,457 minus x all over 100. And just like we've done before, remember these have no variables, so you can simplify these, get actual numbers, take it across, simplify, and then solve. When you solve, you're going to get x is equal to 1,216%. So let's just write out our answers. We have Fe 54, that's given to us 8,536%. We have Fe 56, which is 90,007%. We then have Fe 57, which using our formula, we then worked out as 1,216%. Therefore, Fe 58 is going to equal the balance, or you could say 1,457 minus 1,216, and that's going to give you 0,241%. Now remember, you don't have to necessarily do the long algebraic method or show you're working out. For physical sciences, you can just use your calculator's shift solve function. So you could go here, here, and then shift solve, get that answer. All right, and let's move on now. This is the last question. Lead has 3 isotopes, Pb206, Pb207, Pb208. If Pb207 and Pb208 are present in equal amounts, calculate the percentage abundance if its relative atomic mass is 207,19. Now, no table has been given to us, so let's construct our table. We have mass, we also have percentage. We have 3 isotopes, so let's make enough rows here. All right, so we have 206, 207, 208. Now they tell us, they give us a clue. They tell us that Pb207 and 8 are present in equal amounts. So their percentages will be the same. So x over 100 and x over 100. Now that means 206 is going to be 100 minus 2x over 100. Because it's the remainder. Okay? Now we have enough information, we can solve. So RAM is equal to mass times percentage plus mass times percentage plus mass times percentage. The relative atomic mass is 207,19. That's equal to 206 times 100 minus 2x over 100 plus 207 times x over 100 plus 208 times x over 100. Now, we can solve for x. And when we solve for x, we're going to get that x is equal to 39,66%. Now let's write out our answers. Pb206, Pb207, and Pb208. So 207 and 208 are the same, so they're going to be 39,66%. 208 is 39,66%. That means the balance is going to be for 206. which is going to be 20.66%. Okay, that's it for these questions. I hope you found it useful. If you did, please leave a like, share, subscribe, hit that bell icon. And if there's something specific or a question you have that you want to ask, let me know in the comment section below. And until the next one, bye-bye.